Hi everyone, I'm Derek with CoreOS, and in this video I'm going to explain how Rocket image signing and verification works and how you can use it. This video will be very similar to the signing and verification guide in Rocket's documentation, so if you prefer reading to watching a video, go check that out on the CoreOS website or GitHub. Rocket uses GPG keys and signatures for its image verification, which provide cryptographic guarantees about who created your image and that it hasn't been modified since they created it. Rocket looks for detached signatures for images it fetches and verifies them against public keys it has saved. These public keys make them preloaded with your system, can be manually loaded in by users, and otherwise can be trusted when Rocket is performing image discovery. If Rocket is unaware of a matching public key for a given signature, Rocket will refuse to save the image in its store unless the image insecure option is set via --insecure-options equals image. As a demonstration, let's generate a GPG key, assign an image, and load it into Rocket's store. Note that this demonstration will be using GPG1, and there may be differences with GPG2. To get started, create a file called gpg-batch and populate it with something like this. You can find the contents of this file in the signing and verification guide in Rocket's documentation. You'll want to make sure to change the passphrase to something that only you know. Once you've created this file, we can hand it to GPG to generate our key pair. Just run gpg-batch -gen key, and then the file name. This will create a public and private key pair, storing the public key in rocket.pub and storing the private key in rocket.sec. We can see the keys with gpg-no default keyring --secret keyring /rocket.sec. Note the / is important here, otherwise it will attempt to look for rocket.sec in the default key location. And then --keyring /rocket.pub and --list keys. With the keys created, they need to be marked as trusted by GPG before we can use them to sign an image. This can be done with the previous command, except instead of list keys, we're going to pass the command edit key, then the key ID for the public key that we just generated, and the trust command. And this will ask us what level of trust we want to have for this key, and since we're the ones created it and we know exactly where it comes from, we can trust the key ultimately. And just say yes to be sure. And with that, you can quit out of the GPG prompt. And finally, we have to export the public key so we can tell Rocket to trust it. So pulling up that chain of arguments again, we're going to add onto this armor, so the key is armored, which is required by Rocket. It's just a way of formatting the key when we save it out. Export, and then the email that the key is associated with, in our case it's carly@example.com, and we're just going to send this into pubkeys.gpg. Now, we have a keyring containing our private key that we can use to sign images, and we have our exported public key we can present to Rocket so it knows what public key to trust. Let's get an image we can sign and import. Ideally, here you would create your own image to sign, but for the sake of brevity, let's use an already created image. One of the etcd releases would work great for this. So if we just go to the etcd project on GitHub, we can find one of these releases under the Releases tab, and if we just grab the latest one, we can find a container image right here. So let's just use curl to download this image. So we're going to curl -l to follow redirects, -o into etcd.aci, and then that URL we pulled off of GitHub. We will, however, want to tweak this image slightly to say that we're the ones who made it. We're not using CoreOS as signing key after all. You'll need AC-build for this command, which might be available via your package manager, but in case it isn't, you can just grab it from one of the releases on GitHub. So we're going to run AC-build -modify our etcd.aci we just created, set name, and then to example.com/etcd. Now, with our private key and an image, let's sign our image. So if we go back to the GPG command, we can add the flags output etcd.aci.asc and detach sig etcd.aci. This just says that we're going to make a detached signature for etcd.aci, and we're going to output the contents into etcd.aci.asc. And it'll prompt us to enter in the passphrase that we set on the private key. After entering that, you should see etcd.aci, which is our image, etcd.aci.asc, which is the signature for our image, and we'll still need pubkeys.gpg, which is the public key that we're going to hand to Rocket, so it knows how to verify our signature. If you try to fetch this image into Rocket now, it'll generate an error message about not being able to verify the signature. You can obviously skip image verification to fix this, but that defeats the whole point of this tutorial. So let's tell Rocket to trust our signing key. So sudo rocket trust -- prefix example.com. So we're going to trust the key for any image name that is prefixed with example.com, and then the pubkeys.gpg file will be created. And it'll show us a fingerprint, say it was created by Carly Container, which is the name we provided when we made the key, and asks us, are we sure? Type in yes and hit enter, and the key will be trusted. Now we can import and run images from example.com signed by our key. So if we pull up that same fetch command before, instead of erroring out, it'll successfully verify the signature, and it'll show that it was signed by our key. And this is the hash of the image once it has been imported into Rocket's store. So if we do Rocket image list, we can see that our image is successfully imported into Rocket. Now obviously, distributing your pubkeys.gpg to all of your users and getting them to run a specific Rocket trust command is a little silly, but these keys can be automatically discovered and trusted through AppC Discovery, which I'll be talking about in a future screencast. For further reading on this, check out the Rocket documentation at CoreOS.com or on GitHub. And if you have any questions, feel free to hop in #CoreOS on Freenode and ask away. Thanks for listening.